Good morning, good afternoon, good evening, whenever you are watching this video. So in previous video we talk about how can we calculate the resistance while we are changing the length, area and radius. Okay, in last previous video we talked about if only one is changed, either it may be a length or area or radius. Okay, and in recent previous video we talk about if two we can change. Okay, if we are changing two variable, so what it affect on the resistance. Okay, so I hope you are getting the concepts, and today we will discuss about the series and parallel. Okay, so I'm going to rough this one. So students, today we will talk about the series and parallel. Series and parallel combination. Series and parallel combination of resistance. Okay, so there are two methods of arranging the resistance. Okay, one is series and one is parallel. So firstly we will discuss series. Okay, so we are going to discuss the series combination. Okay, so suppose that you have a resistance. And resistance, the symbol of resistance is denoted by a diametrical symbol. Okay, diagrammatical symbol this is. So this is denoted by this one. Okay, so this is a symbol of resistance, and I have a resistance. I have a three resistance, and I am going to arrange these three resistance in a series. Okay, there are two methods to rearrange, means one method is series and one method is parallel. So now I'm going to tell you how can we arrange these three resistance in the series combination. So series combination is very easy. So if we are going to arrange these three resistance in a series combination, so we put this resistance in the front of the back resistance. Okay, so this resistance here. Okay, and we put this resistance here. Okay, so this is a R1, this is a R2, and this is a R3. Okay, there are three resistance. So this is a series combination. If we are arranging consecutively, if we are arranging the resistance in consecutively, we can say we are arranging the resistance in a series combination manner. Okay, so now if I'm going to calculate the total effective resistance, what is the total resistance of these three? So how can we calculate? It's very simple. So this is R net is equal to R1 plus R2 plus R3. So this is the total resistance. This is a total resistance. Okay, suppose that I have three resistance. Now I'm going to explain the example. Suppose that this is a 12, this is a 15, and this is a 20, and if I'm going to ask just calculate the total resistance, so how can you calculate? You know very well R net is equal to R1 is equal to R1 plus R2 plus R3, and you know very well what is R1 is 12, and what is R2 is 15, and what is R3 is 20. So 20 and 15 is equal to 35, and 35 and 12 is equal to 47. So R net is equal to 47 ohm. So this is my final answer. So like this way you can calculate the resistance. Okay, this is pretty simple. You can calculate easily. Okay, now I'm going to discuss the parallel combination. What is parallel combination? Okay, so suppose that you have a three resistance, this one, and this one. Now I'm going to arrange these three resistance in a parallel manner. So how can we arrange? So if we add the resistance like this way in consecutively manner, so we can say this is a series. But if we are arranging like this way, if we are arranging like this way, so this is a parallel manner. Okay, so suppose that this is a R1, this is a R2, and this is a R3. Okay, so if I am going to ask you what is the total resistance in this diagram, so how can you calculate the total resistance? Simply, it's just simple. 1 upon R net is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so like this way we can calculate. Okay, so if I'm going to ask you, this is the value of 12, this is the value of 15, and this is a 20. Okay, the R1 is 12 and the R2 is 15. This is a ohm, this is a ohm, this is a ohm. Okay, so if I say R1 is equal to 12 ohm and R2 is equal to 15 ohm and R3 is equal to 20 ohm, so how can you calculate the total R net when the resistance are arranged in a parallel manner? So how can you calculate? So just put these value in this equations. This is the formula. R net is equal to 1 upon 12 plus 1 upon 15 plus 1 upon 20. So 1 upon R net is equal to 12, 15 and 20. What is the LCM of 12, 15 and 20? It's I think 60. Am I right? Okay, I'm right, 60. So 60. Okay, now 12 5 just 60, so 1 into 5. Okay, plus now 15 4 just 60, so 1 into 4. Okay, and 23 just 60 plus 1 into 3. Okay, just please calculate this one. 5 1 ja 5 plus 4 1 ja 4 plus 1 3 1 ja 3 plus 3 upon 12. Okay, so 5 and 4 9, 9 and 3 5 and 4 9, 9 and 3 12. So this is 60, this is 60. Okay, 5 and 4 9, 9 and 3 12. So it is 12 upon 60. 1 upon R1, oh sorry, R net. 1 upon R net, 1 upon R net is equal to 12 upon 60. So 12 1 ja 12 and 12 5 ja 60. So 1 upon R net is equal to 1 upon 5. And if I reverse this R net, so R net is equal to 5 upon 1, or R net is equal to 5 ohm. Okay, so like this way we can calculate the resistance. Okay, there is nothing to worry about that. If you have the question in series, and if you have the question in parallel combination, you can calculate. If the resistance are arranging in a series manner, you can directly add the resistance and then you will get the R net, means final resistance. And if the resistance are arranging in a parallel manner, you can just inverse the whole resistance separately and add them, and then you will get the final R net or final resistance. So now dear students, I hope you get it note down, and now I'm going to give you one questions. Okay, now I'm going to give you one questions. Please note down the questions. A wire of resistance R, a wire of resistance R, a wire of resistance R is cut into n equal parts, is cut into n equal parts. It cut into n equal parts, and these parts are connected in a series combination, and these parts are connected into series combination, series combination. Okay, a wire of resistance R is cut into the n equal parts and these parts are connected into the series combinations. Find the equivalent resistance of the combination. Find the equivalent find the equivalent resistance of the combination. Okay, suppose that, what is the question? Please clear your concept. Suppose that this is a resistance you have. Okay, this is a resistance and this is a resistance, and you cut these resistance in n equal parts. Okay, in n equal parts. Suppose that you have a resistance and you cut it down into n equal parts. So now the resistance is look like 1 2 3 4 1 2 3 4 over 4. So 1 2 3 4. Okay, so now suppose that this is total R. Suppose that this is total R. This is total R. Now this is R by N, R by N, R by N, R by N. Okay, because we cut it down into the n equal parts. So the new resistance is R by N, R by N, R by N. So you know very well, when we are going to arrange the resistance in a series manner, so I have a formula, R net is equal to R1 plus R2 plus R3 plus dot 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 Rn. Okay, जितने भी resistance है you can calculate. You can just put the value and you can calculate. So here R net is equals to the R1. What is the value of R1? The value of R1 is R by N, and the value of R2 is R by N, and the value of R3 is R by N, and the value of R4 is R by N, means okay, R by N. So now please calculate. So please calculate. How can you calculate? So can we write this R net is equal to R by N, R by N, R by N, R by N. Okay, this is the n equal parts, na? So we can dot 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 n, dot 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 n. Okay, dot 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 n. Okay, so can we write this R by N, R by N into, if this is a 4, this is a 4, 1 2 3 4, so we have to directly multiply by the 4, but this is a n, this is a n equal parts, this is a n. Okay, many n, R by N, I don't know how many n they are there. So R by N into n, can we write like this? Can we write like this? R by N into n. Okay, so can we write like this? R by N into n. So from here this n is cancelled out by this n, and you will get R net is equal to R. Okay, you will get R net is equal to R. Means, what is the conclusion of this question? Why I am asked these questions to you? What is the conclusion of this question? The conclusion of these questions, if you have the resistance and you cut it down into many equal parts, so if the resistance, if the before cutting this resistance, the resistance is I think means suppose 120 ohm, 120 ohm. So, and if I cut it down into so many parts, in n parts, and now again I am adding these whole resistance, then I will get 120 ohm. Okay, so that's why I asked these questions. Mean there is no effect in the series, there is no effect. If I am going to cut it down, the resistance, I am breaking the resistance and again I am adding, so there is no effect. Okay, before this is 120 and after adding this is also 120, so R net is equal to the R, and we know very well there is a resistance is R, means before cutting down the resistance is R. So I hope you are getting the concepts. Now students, you have same question, you have the same questions, and now just I am changing a little bit. A wire resistance R is cut into the n equal parts, and these parts are connected in a parallel combination. Parallel combination. Find the equivalent resistance, and you know very well, suppose that you have a R and you cut it down into R by n, R by n, R by n into n equal parts. So you know very well what is the R net when we are going to add the resistance in a parallel manner. So 1 by R net is equals to 1 by R1 plus 1 by R2 plus 1 by R3 dot 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 1 upon Rn. Okay, this is a formula. We already discussed this formula in previous video. Okay, when we are going to arrange the resistance in a parallel manner, so this is a formula we already discussed in previous video. So how can we calculate the total equivalent resistance? We can calculate, you know very well, 1 upon R net is equals to 1 upon R1, and R1 is a, this is a R1, this is a R2, this is a R3, this is a R4, okay, dot 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 Rn. Okay, so this is a R net and 1 upon R1, so R1 means R upon n, and this n is shifted toward the in numerator because this is in divided. Okay, and you know very well this is a basic calculation. So what it becomes n by R. So n by R. Okay, so n by R plus n by R plus n by R plus n by R plus dot 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 and up to soon. Okay, so same, what is the R net? So 1 upon R net is equals to a n upon R into n. Can we write like this? Okay, now please calculate the 1 upon R net. 1 upon R net is equals to n square upon R, n square upon R, and if I reverse these whole things, and I am going to calculate the R net, so this is the R upon n square. So please make note down. So dear students, now I am going to ask you one question. Same, if a wire resistance of R is cut into the 5 equal parts, okay, equal parts, and these parts are connected into the parallel combination, find the equivalent resistance. So how can we calculate? You know very well this formula I have. Okay, this formula I have. So what is the R net? R net is equals to the R upon n. How many n are there? 5. So 5 square. So R net is equal to the R upon 25. Okay, so resistance it becomes R upon 25. This is the final answer. So this is a simple things. Okay, this is the basic calculations. I know you know very well. So students, I'm going to rough. I hope you make note it down. So dear students, suppose that you have a circuit, there is 2 resistance. Okay, there's 2 resistance, and when battery is connected, potential difference is connected to this circuit, and this is a R1 and this is a R2, and I applied a voltage. Okay, and I applied a voltage. So suppose that current is moving from this direction to this direction. Okay, suppose that I is comes from this way, so same I here, same I here, okay, and same I here. So this is a series combination. This is a series combination. So in series combination, in all point, in all nodes, the current is same. The current is same or constant. Okay, the current is same or constant. In a series combination, the current is same, but voltage is different. Voltage is different means here means in this the voltage is not equal to the this voltage, means V1 is not equal to the V2. So voltage is not same or constant. So please make note it down. Only in series combination, okay, only in series combination. In series combination, current is same and constant at any point. At any point, okay, but the voltage is not same or constant at any point. Yeah, at different point, okay, at different point after resistance. Okay, please make note it down. Okay, and if we are going to discuss in the parallel combinations, so this is a parallel combination. This is a R1 and this is a R2. Suppose that this is a I and I comes from this way. Okay, so suppose that यहाँ से 20 इलेक्ट्रॉन निकले. ओके, तो 20 इलेक्ट्रॉन निकले तो यहाँ पे जाके क्या हो गए, कंफ्यूज आ गए. इस नोट्स में जाके कंफ्यूज हो गया कि कहाँ जाना है, यहाँ जाना है कि यहाँ जाना है. तो कुछ तो चले जाते हैं इसमें और कुछ चले जाते हैं इसमें. तो इसमें तो एक ही पाथ मिल रहा है. सपोज दैट इसमें 20 इलेक्ट्रॉन निकले, तो 20 इलेक्ट्रॉन निकले तो कंफ्यूजिंग का तो कोई केस ही नहीं है, सीधा जाना है. ओके, तो जितने यहां से इलेक्ट्रॉन जाएंगे उतने बाहर निकलेंगे, मींस करंट इज सेम. ओके, बट यहां पे क्या हो गया, दो पाथ मिल गया. एक पाथ ये मिल गया, एक पाथ ये मिल गया. तो करंट कंफ्यूज आ जाता है कि किधर जाएं, ऊपर जाएं कि नीचे जाएं. ओके, तो कुछ पार्ट यहां चले जाता है और कुछ पार्ट नीचे आ जाता है. ओके, तो सपोज दैट यहां I1 चलेगा तो यहां I2 चलेगा. लेकिन यहां पे जो वोल्टेज है वो वोल्टेज क्या होती है, सेम होती है. वोल्टेज डिफरेंस नहीं होती है. जितनी वोल्टेज यहां पे होगी उतनी वोल्टेज यहां पे होगी. तो इन अ पैरेलल कॉम्बिनेशंस, इन अ पैरेलल कॉम्बिनेशन, in a parallel combination, in a parallel combination, current is not same or constant at any 2 point. Okay, and second, but voltage is same at any point. At any point. Okay, so please make note it down. Please make note it down. So dear students, आज के लिए यहीं पे बाइंड अप करते हैं. ओके, प्लीज इसके आप नोट्स बनाते रहिए और ये बहुत इंपॉर्टेंट है, आपको आगे भी काम आएगा. 8th में तो काम आ ही रहा है, 9th में भी काम आएगा, 10th में भी, 11th में भी, 12th में भी. तो इसको बहुत केयरफुली पढ़ें. एंड इफ यू हैव एनी डाउट्स तो यू कैन फील फ्री टू आस्क इन व्हाट्सएप एंड इन कमेंट सेक्शन बॉक्स. ओके, टेक केयर, बाय बाय, गुड नाइट.